So now in chapter 4, we're ready for condensation. And we've reviewed everything about humidity and dew point and saturation. Condensation has several different types, and they're based on altitude. There's types that are at the ground level, types that are near the ground level but a bit above, and other types that are in the lower atmosphere. We're going to start at the ground level with dew and frozen dew and frost. Then we'll go to the near ground level with fogs and up into the lower atmosphere with clouds. When we're thinking about condensing water vapor, we need to think about saturating the atmosphere with that water vapor. We need to meet this saturation vapor pressure line that has become really familiar to us, because that is the line where there's an equilibrium between the pressure of vapor escaping a liquid surface and the pressure of vapor returning and condensing on that liquid surface. So that's the line where condensation starts, and that's the line where we need to get to mathematically when we're thinking about our atmosphere and the amount of water vapor in our atmosphere. Because remember, when the temperature of the air equals the temperature of the dew point, that means we're on that saturation vapor pressure line, and that means we're ready to start condensing. Here's an example. A beautiful day, 87 degrees, nice and dry, feeling great. How do you condense water vapor on that day? How do you produce dew on that beautiful dry day? There's two ways you might be able to do that, and they both can be seen on this graph. Let's say that's the 87-degree day that's nice and dry at about 20% saturated vapor pressure or actual vapor pressure at about 20 millibars. Nice and dry and feeling great. To get to condensation, we could add more water vapor and get up to the saturation vapor pressure line. We'd be adding an enormous amount of water vapor to get to that line. It's not feasible since our atmosphere tops off at about 40 millibars for the maximum amount of water vapor in the air. So that's not really feasible. And we find that there's another way to reach saturation that we use much more often. And that way is to decrease the temperature of the air. And you know that you'll usually get dew at night when the temperature goes down. So you can lower the temperature of the air and get to the saturation vapor pressure line. That's generally what we do to condense in our atmospheres. When we talk about the condensation types at the ground level, and we talk about reducing the temperature in the environment, we're talking about dew, frozen dew, and frost. Let's look into the differences between them. When it comes to dew, that is condensation at the ground level, at the grass level, where objects like grass or leaves or metal cool to the dew point and then generally go below the dew point. And that condensation is mostly found on clear, calm nights without a lot of wind to evaporate that and move that vapor away. So you need that vapor to sit on the grass and cool, and that leads itself to clear, calm nights. When we think about that, we can look at the difference between those nights when we wake up in the morning and there's dew on the ground and the nights when we wake up in the morning and the grass is dry. So what's the difference between dew in the morning or dry grass? When we look at this graph here, we note that the temperature at the dew point is noted with this sign. And here it is here, temperature of the dew point. And temperature minimum, I call it temperature minimum object, but it is in green here. that is going to be the temperature of the grass or of the leaves or of the metal, like your car sitting out overnight. That is the nighttime minimum temperature that that car gets to, that car metal gets to, or the grass gets to. So when the temperature falls overnight, it drops to the temperature of the dew point and starts condensing, and often goes below for a nice healthy dose of dew on the grass. That's how we form the dew. For the nights when you wake up and there's nothing on the grass and the grass is dry, there's two things that could have happened there, but they both involve the same thing. The temperature of the grass or the leaves or the metal never reached the dew point. So therefore, condensation never started. This can happen below freezing for dry, cold grass, or it can happen above freezing for dry, warm grass. Either way, the temperature of the grass or the leaves or the metal never drops to the dew point level. So there is no condensation there. Contrast that with dew and frozen dew. It's the same thing. We've got our dew point temperatures here above freezing. And we've got the grass, here's a blade of grass here, or the leaves, or the metal of the car that has been dropping temperature overnight as it radiates off its heat from the day. And as it drops it, it meets the dew point temperature and starts condensing, and that would normally produce dew. But if that temperature keeps dropping for the grass or the leaves or the metal below freezing, then that dew droplet can freeze, and that is frozen dew. So it is when the temperature of the grass or of the object goes below freezing that you will get that condensation to freeze. It's really a beautiful event, and that is frozen dew. Contrast that with frost. With frost, you never get condensation. You actually go straight from water vapor to ice. How do you do that? Well, this forms on very cold and clear and calm mornings. It is when the grass or the leaves and the metal are at a lower temperature than the dew point temperature, and that dew point temperature is lower than freezing or at freezing. So in other words, this minimum temperature of the grass fell during the night as it radiated away its infrared energy. And as it fell during the night, it fell below the freezing point. Then it got to the dew point, which was lower than freezing, and then it kept going. So because the dew point is lower than freezing, we don't call it a dew point anymore. We call it a frost point when it is below freezing. And so this grass or leaves or metal went and crystallized right here below freezing, and then continued on to drop, and all of that vapor went from water vapor directly to a solid crystal. And that's what you're seeing on the frozen windshields. You're seeing that beautiful crystal. So when we look at that difference between dew and frost, a lot of times it comes down to where the dew point is. Is the dew point above freezing, or is the dew point below freezing? And that helps you to decide whether or not you're going to see dew, frozen dew, or frost. See you on the next video.